For this one right here, we have an objective function has been given to you, so we do not need to figure that out on this problem. And they have given us two constraints. So I need to graph the two constraints. And they did say we're going to stick to the first quadrant. So I'll just worry about the first quadrant. For the constraints, we'll graph them both. Find the intercepts. For x plus y is less than or equal to 11. My first part is to graph the straight line. X plus y equals 11. It will be a solid line because we have less than or equal to. I'll set up my little chart for my intercepts. If I pick 0 for x, I'll get 11 for y. And if I pick 0 for y, I will get 11 for x. I'm going to go to the graph and plot those 2 points. Select the line tool. Secure the line at 11 on the y-axis and 11 on the x-axis. And it will put in this line. It's going to limit you to the first quadrant. When I shade, I'm going to shade below that line, so that little triangle. I'm not going to shade it yet. I'll wait till I have both of these inequalities graphed. For the second one, we'll graph x plus 2y is less than or equal to 12. For that, graph the straight line, x plus 2y equals 12. I'll do my little chart. On these problems, you have to find the intercept because some of them will be corner points. So we'll do the intercepts here. If y is 0, this 2y would be gone. It's 2 times 0. X equals 12. So the x-intercept is 12. The y-intercept, plug in 0 for x. And you get 2y equals 12. Y equals 6. So I have on my graph 12, 0, 0, 6. I'll take my straight edge and connect those 2 dots. Now, because you're graphing this on the computer, you probably have a much better picture than I have right there. You probably could guess the intersection point from the graph. You know, there's 3 ways to find the intersection: graphing, substitution, or elimination. And because you have the graph on the computer, probably could look at this. I think I will guess 10, 1 for the intersection point. If that's my guess, I need to look back at my equations. Does that point fit in here? 10 plus 1 equals 11. Yes. Does it fit in the other one? 10 plus 2 times 1, that does equal 12. There's my intersection point. So let's see. Let's kind of regroup here. I have the graph. Find the value of the objective function at each corner point of the graphed region bound by the constraints and in the first quadrant. X is greater than or equal to 0. X equals 0 is the y-axis. Y equals 0 is the x-axis. So they're just saying it's bound by those 2 lines as well. The values of the objective function, let's first write the corner points, and then we'll put in the value. I'll do my little chart here. Corner points. And the objective function was z equals 7x plus 13y. The corner points, do not forget 0, 0. If you forget it, it's going to mark it wrong because they want all of them on this problem. As far as your intercepts go, it's going to be the smaller of the two y-intercepts, and it's going to be the smaller of the two x-intercepts. So I have 0, 6. For the x-intercept, that was 11, 0. And the intersection point was 10, 1. For the objective function, 0, 0, z will be 0. For 0, 6, z is 7 times 0 plus 13 times 6. I'll just type that in my calculator. 13 times 6, 78. For 11, 0, z equals 7 times 11 plus 13 times 0. That will be 77. And finally, the last one, 7 times 10 plus 13 times 1. That is 70 plus 13. That should be 83. On my problem, the values of the objective function are, and they did not say type them in any certain order, so I'll do 0, 78, 77, 83. Part C, determine the maximum value and the values of x and y where the maximum occurs. The maximum is 83. The maximum value, z equals 83. The maximum occurs, type an ordered pair at 10, 1.